Video number 6. So this first question that we're going to talk about here is a question dealing with the angles inside of a circle. So in this first question, we are looking for the information, and they've provided us with a couple things. That first thing is that we've got angle RPS. RPS is this exterior angle out here, 35 degrees. They've got this arc RS here, so which is all the way over here. So this big arc is 121 degrees, and we are asked to determine and state what arc WT is. So we'll call it X for this case. So again, noticing that we have an exterior angle here, when we're dealing with an angle that is outside of the circle, is created here by two secant lines. We have a little kind of a formula here that says the angle is equal to what I refer to as the big arc minus the little arc divided by 2. And in this case, we'd have angle, which is the 35 degrees, is equal to the big arc, which is 121 degrees in this example. And we've got the little arc, which we don't know, so I'm going to call it X, all divided by 2. So now, once I have the information plugged into my little formula here, it's just a matter of solving for X. So to solve for X here, let's eliminate this 2 on the bottom. So if we divide each side of the equation by 2, that will eliminate that part. We're going to be left with 70 equals. I've got 121 degrees minus X. And in this case, whatever you feel most comfortable with, I think is easier if you just add the X over. So I got X plus 70 equals 121, and subtract the 70 from both sides. If you want to subtract the 120 over and then divide by -1, that's perfectly fine too. That's going to give us an answer of X to be 51 degrees. So make sure you go back, answer the question. This is determine and state what the arc WT is. So arc WT is going to, in fact, be 51 degrees. All right, so again, knowing that little shortcut formula for dealing with a secant line and another secant line intersecting outside the circle, that's our exterior angle. All right, question number 2. We've got a parallelogram ABCD is adjacent to rhombus DEFG as shown below, and FC intersects line AGD at H. So again, they give us some information here. So angle B is 118 degrees. We've got, that's this part here. We've got angle AHC. So AHC, that's this one here, 138 degrees. And we are asked to determine what GFH is. GFH, so we're looking for this over here. All right, so with this information, the fact that we're told that we have some parallelograms and a rhombus, so we now have the ability to kind of incorporate here our properties of both of these figures. So that's going to be helpful and useful when we're trying to figure out other angle measures. So let's start off by figuring out what other things would be. Since this one's 118 degrees, angle B, and this is a parallelogram, I now know that angle D, the opposite sides of a parallelogram, are congruent along with their angles. So therefore, this one is also 118 degrees. So that's one piece of information that's good to know. And the other thing here is, since I'm looking for this one, I've got a couple options. I could figure out what the other angles inside this triangle are here, and then this angle plus this angle would equal the third angle, would end up adding up to 180 degrees. That would be our missing angle. The other thing is, since we know it's a rhombus, just like a parallelogram, opposite angles are congruent. So if I can determine what this angle is here, and I can because I know that these two together are supplementary. So if I have 118, right, so 180 minus the 118, right, that gives me 62 degrees. So this is a 62 degree angle over here. So now this angle and this big angle are both 62 degrees. So if I can figure out what this little part is over here, I can simply take that away from the 62 and I have my my angle that I'm looking for. So the key is finding out that little piece. That's another way of doing it. And I think that's the way to kind of go here. So with that being said, I kind of can utilize, again, the fact that I have another supplementary angle here of 138. So if I do the 138 minus, 180 minus the 138, right, that gives me 42 degrees. So now I know that this is 42 degrees. And again, the reason that's important is because in a rhombus, we know that opposite sides are parallel. So now I know that this and this are parallel to each other. That would make this be a transversal. So once I know that that's a transversal, I now can say that I have this Z-like shape. So if that's 42, this is also 42. So once I now know, back to my fact that this whole thing is 62 and this whole thing is 62, let's call this X for now. I can now say that 62 has to equal the sum of 42 plus X. So if I subtract the 42 from both sides, I now have that X is equal to 20. Therefore, angle, oops, happened there, angle GFH is in fact 20 degrees. So that's just one way of answering this question. Again, we could have kind of found out what FGH was, said that angle plus 42 plus X, taken that, said that all of that has to equal 180, and solved for X that way. But in this case, I thought this was one of the quickest ways to kind of get to this answer, and noticing that this angle is 62 and the other one is also 62, utilizing the properties of both parallelograms and rhombuses. All right, third question here. In a rhombus, VENU, diagonals VN and EU intersect at S. So let's just kind of draw ourselves a little picture here. So we've got a rhombus. Again, doesn't have to be perfect. It's just a sketch. As long as you put the letters in order around the figure, it doesn't matter which order you go, where you start. But it does tell me that diagonal VN, and we have a diagonal EU. The important things is that VN, so all of this was 12, and all of this was 16. So if that's true, in the fact that it's a rhombus, the rhombus portion of it, again, the properties of a rhombus tell me that the diagonals, they bisect each other. So that's one thing that happens. So these are going to be equal, and those are going to be equal. So if this whole thing of EU is 16, that means this piece is 8, and this piece is 8. And if VN is 12, that means this is 6, and this is 6. The other important property of a rhombus is that the diagonals are perpendicular to each other, right? So if these are perpendicular to each other, now I can hopefully notice that I have a right triangle here, and I have a right triangle with two sides. So once I know 2 out of the 3 sides of a right triangle, I could use Pythagorean Theorem. And in this case, the legs would be the 6 and the 8. Again, doesn't matter who you call A and B. And that's going to equal, we'll call this side over here X or C. Doesn't matter. We can just call it VE. Does not matter. So 36 plus 64 equals X squared. So that's 100 is equal to X squared. If I take the square root of both sides, I get X to be 10. Now be careful. As you can see, choice D is 10. So it's very easy to just jump to that being your answer. But again, you have to answer the question. The question said, what's the perimeter of the rhombus? So perimeter is add up all the sides. So in this case here, we know it's a rhombus, so all of these sides are equal. So they're all going to be 10 now, right? So add them all up, or in this case, I can just simply say 4 times 10 is going to equal 40. So perimeter equals 40, giving me choice B as my correct answer. So just be careful. Make sure you answer the question, especially for a multiple choice question. It's very easy to just jump to that choice D one here as 10 because we got X to be 10 when we started. So be careful, and otherwise it's not too bad of a question as long as you know your properties. All right, last one here. Another multiple choice question. So we've got here in this diagram here, we have a rectangle, with given endpoints. And it says which transformation will not carry, again, keyword there is not carry the rectangle onto itself. So this is kind of a process of elimination question here. So start looking at each one and see what we got. So a reflection over the line, y equals x. So let's just kind of sketch that one out here. So y equals x, that's going to be this line here. Right? So if I was to reflect over that line, C would go to B, D would go to A would go to D, and B would go to C. So that's going to look exactly the same here as it started. So it is going to, in fact, transform onto itself. So can't have that one. So that one's out. Just put a little X next to that one. 2, reflect over the line y equals negative x plus 10. So that's a little weird of a question. So we got to figure out where that is. So that means a slope of -1 and a b-intercept of 10. So a y-intercept of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it crosses here, and it goes down 1, left 1, down 1, left 1, so on and so forth, right? So if I was to now connect that line here, that's going to be this line here. Right, and if we reflected that over here, again, A would go to B and B would go to A, C would go to D, D would go to A, so it would look exactly how it is right now. Therefore, it too would reflect onto itself. So that one's got a little X, that's the one's going to be false. And then the last two are rotations. So again, a rotation of 180 degrees, that's a good sign because both 180 degrees could rotate onto itself. It all depends on the point. So we've got 2 points. So 6, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So if I put that point right here, that's 6, 6. 5, 5 is right here. All right, so which is, if you look at this, especially since I now have the 2 lines here, that's the center of that rectangular area. So if I rotated around that, everybody would end up being where they are now. It would look exactly the way it is. They'd just be in opposite sides, but it would look exactly the same. Therefore, 5, 5 would not work because that does, in fact, get it onto itself. So the last one that doesn't work is C. And again, because this is a point on the edge of the figure, so if I was to rotate 180 degrees, all the points would not land where they currently are, and therefore it would not carry itself, the rectangle would not be carried onto itself. So choice C is your final answer there for that one. And that completes the video for video number 6. Again, hopefully if you have any questions, make sure you go through them. Feel free to try the questions on your own as you go through.